Hey, I'm back already with question number 22. That last one was so long that I thought I was done. And I also want to let you know that when I showed you the problems at the beginning, I forgot for 21J, this is 21J, to show you that problem to begin with. So if you were wondering, it's here. Maybe you got to the end of the other video and realized, but that answer is right here for 21J. So let's do 22c and e. So this is page 241, I think. 22c and e. All right, so C reads, hematite is converted to molten iron in a blast furnace and then is poured into molds. The balanced equation is this. Oh, I better write that equation because you've seen how important these equations are. I'm going to leave off all the solids and things like that for now. Because they're really not important for what I want to do right now. So C says, how many moles of hematite must react to produce 760 kilograms of iron? So I have 760 kilograms. Because let's be honest, if we're making iron, we're using really big quantities. So we have to start out with those really big quantities to make this more realistic. But we don't use those really big quantities in our equations. We have to convert to grams. So going way back, and this is iron, going way back, we know that 1 kilogram of iron is equivalent to 1,000 grams of iron. Now we're going to make our molar mass sandwich. Actually, what am I doing? Nope, I am doing C. Okay, whew. I was getting myself confused here. Never mind. Okay, now we make our molar mass sandwich. Actually, it's not a molar mass sandwich because we're just going to moles, aren't we? So we have an open face sandwich here. So we need our molar mass of iron. We can get that right off of our periodic table, and that's 55.85 grams of iron. And then that is 1 mole of iron. So we've gone from grams to moles. I then have my mole ratio, which is 2 in front of the iron. I am going to hematite, which has nothing out front, so it's 1. I'm in moles, which is where I want to go. So multiply across the top, divide by what's on the bottom, and I get an answer of 6,800 moles of hematite. Okay, going on to D. I am given, Mom? No, not right now. How many moles or how many grams of carbon dioxide will be produced when 40 moles of carbon monoxide react? So I start out with my 40 moles of carbon monoxide. I go up here and I'm already in moles. All right, so I can go right to my mole ratio. 3 moles of carbon monoxide. I'm going to carbon dioxide. Oops, I wrote my equation down wrong. Let me double check that equation. Yep. Okay, so it's 3 in front of both of them. So it doesn't matter. And I am not quite there yet because I need to have my molar mass. So I need 1 mole of carbon dioxide. Now my molar mass, calculate it down here. For carbon, it's 12.01 grams for my periodic table times 2 times 16 grams for my oxygen. So the molar mass of carbon dioxide, when I do the math, is 44.01 grams. So I put that on the top here. I cancel out, multiply across the top, divide by what is on the bottom, and I end up with 1,760 grams of carbon dioxide. And then for E, they give me what mass in kilograms of iron is produced when 299 kilograms of hematite react. Okay, so I start out with my 299 kilograms Fe2O3. Now I cannot stay in kilograms, I have to convert to grams. So I know that 1 kilogram Fe2O3 is 1,000 grams of Fe2O3. I need my molar mass. So 2 times the molar mass of iron plus 3 times the molar mass of oxygen. And I get a total of 159.7 grams Fe2O3. Okay, so I have to go to convert. I put my 159.70 grams of Fe2O3 on the bottom. I put my 1 mole of Fe2O3 on the top. Now as I'm going along, these are canceling nicely. Now this was my bread. I'm on to my meat, which Fe2O3 up here has nothing in front of it, so it's a 1. So 1 mole Fe2O3. I am converting to iron. Iron has a 2 in front of it, so 2 moles of iron. I now can convert. I need my other piece of bread, so 1 mole of iron is 55.85 grams of iron. I'm trying to squeeze this in because to get that other conversion in here. Now I'm in grams, I need to be in kilograms. So we know that 1,000 grams of iron is 1 kilogram of iron. That cancels. So when I multiply across the top, divide by what I have on the bottom, I get 209 kilograms of iron. And so that is problem number 22.